Hello friends, welcome back to my channel. Myself is Ravindra. I am studying in SVC college. Today subject is maths and I teach about the why is A to Z transistor important to in discrete time signals. So this is the topic about what we are learning today. Myself is Ravindra. I am studying in SVC. I am in the third sem second year, section Brahmos, subject maths, USN 1V23EC090, subject code is BMATHE EC301. So this is the subject code. Introduction to Z transform. These are the proper property name and illustrations you have learned in the textbook. So you learn that. So the Z transform is a powerful mathematical tool used to analyze the discrete time signals. It transforms our discrete signals from the time dominant into the complex frequency domain. So these transformations adds in understand the properties and behavior of discrete signals. So this is the explanations about introductions to Z transform. So these are the properties. What the properties name linearity. So that formula left shift by 1, left shift by 2, left shift by a, right shift by n, multiplications by time, scales in z, scales in time, convolution, initial value theorem, final value theorem of final value. So these are the important properties names and their formulas is has to be given. Definitions of Z transform. That is, Z transform of discrete time signals is defined as a sum of the signals multiplied by a complex exponential. So mathematics it is represented as z of x is equals to sum of. These are the formulas important. This you have to represent. This represented allow for the systematic approach to signals analysis and processing. So these are the importance what we have to learn about these signals. So next, important of frequency analysis. What are the important things we have in frequency analysis? That the Z transistor transform facilitates the analysis of signals in the frequency domain by examining the poles and zeros of the Z transforms. One can determine the system stability and frequency responsibility. This is the crucial for designing the filter and systems that manipulate the signals efficiently. So next is stability analysis. What is the stability analysis? So these are the main important things we have learned in this topic, that stability analysis. Stability is a fundamental characteristic that determines the behavior of a systems over time. So that Z transform provides a clear credentials for stability based on the locations of poles in the Z plans. So this help engineers design the reliable systems that perform an expected without divergence. So these are the important that we have to learn in this. So next is system categorization. So what is system categorization? These are the diagrams and these are the explanations about the system categorizations of Z transform. Systems can be categorized using their impulse response via the Z transform. The relationship between the input and output signals can be described in terms of transfer function. These categorizations is essential for understanding the system's behavior, designing control systems. So these are the categorizations and these are the formulas that you used in this formula. Finite impulse responsibility, derivations of impulse responsibility. So next is computational simplifications. The Z transfer simplification, the mathematical handling of discrete time signals. So it transform difference equations into algebraic equation, making analytic easily. These simplification speeds up computing in signals processing applications. So Z transform properties name, so illusionation. So con- convolutions in Z dominant. So convolutions in the time domains corresponding to multiplications in Z domain. So this property significantly reduces of the complexity in calculation output for linear systems. It is the particular benefits of the digital signals processing where convolutions are prevented. So handling non-causal systems. The Z transform allows for the analysis of non-causal systems which are impossible to handle in the time domain. So this concludes that the main things. So handling the non-casual systems, this is the main important things we have to learn in these sessions. So next is the design of digital filters. These are the definitions of the digital filters. Designs the heavily refills of the Z transistors to achieve the describes the frequency characterization. So the transistors adds in determinations to filter the coefficients based on the specific requirements. So this is the crucial in applications like audio processing, communications, and the control systems. These are the things we have to learn this, and these are the formulas to design it. So understanding time shiftings, the Z transform providing a clear way to analyze the time shiftings in signals. So time shiftings properties can be easily determined, aiding in the understanding of systems response. This is essential for the applications where the time is allocated for signals. So inverting Z transform is used to convert the back the domains to the time domain. This process allows the engineers to obtain the original signals after processing in the Z domain. So understanding the inverse is essential for the practical applications in signals process. These are the main important things we have to learn, and formulas we have to learn in this section. So region of converse ROC. So these are the main important things. So applications of in control systems. This also you have to study. The transform is widely used in the analysis and designing of the digital control systems. So it helps that. So relations to Laplace transform. What are the relations that provided in Laplace transform has been studied. So implementations in software tools. These are the software tools. What are the implementations that have been taken in this section? So real world applications is main important. These are the definitions. Pause it and note it. So next is education important. Education is important for our this generations. For education is more important. Challenges and limitations. What are the challenges? What are the rights we have to observe in the Z transfer? So next is future developments. So these are the important things we have to study in this topic. So these are main things. What is the topic's conclusion is the Z transform is a visual tools for analyzing and processing the decrement time signals. Its advantages in stability analysis, filters, designs, and computational efficiency are numericals. Understanding the Z transform is essential for anyone working with digital signals process. So thank you one and all who are watching my videos. So please support me and subscribe my channel. So thank you one and all. Thank you.